In this lecture, we will discuss about Rutherford's nuclear model, which was presented by Rutherford in 1911 to replace the Thomson's plum pudding model. Rutherford and his students, Geiger and Marston, had performed gold foil experiment to understand the structure of the atom. According to Rutherford's model, atom is tiny and dense. It has positively charged core called nucleus, and the whole mass of the atom is concentrated in it. Next, the electrons are revolving around the nucleus. In this setup, alpha particles emit from the radioactive sample and hit the gold foil. They found that most of the fast moving alpha particles passed through the gold foil and hit the fluorescent screen. This is because most of the space of the atom is empty, and it means positive and negative charges are not evenly spaced. Next, they found that few alpha particles were deflected from their path by small angles. This is because when alpha particles passed near to the nucleus, they are deflected by small angles due to positive charge on nucleus and because of a repulsive force between nucleus and alpha particles as well. They also found that few of alpha particles were rebounded. This is because when alpha particles made head-on collisions with the nucleus, they are rebounded. This proves that there is a nucleus present at the center of the atom. These results prove that plum pudding model is not correct because based on Thomson model, there is nothing dense or heavy inside the gold atom to deflect the alpha particles. Hence, alpha particles will pass straight through the foil and hit the fluorescent screen. But Rutherford observed that alpha particles are deflected by small angles are rebounded back on the same angle as well. Hence, according to the Rutherford model, there is something dense and heavy inside of the atom. Because of that heavy stuff inside of the atom, alpha particles are deflected by small angle or even in some cases rebounded back. Now here are a few questions. First, why did they select radioactive element? The answer is because they need a source that emits alpha particles. Next, why did they choose alpha particles? Answer is because alpha particles are high energy and heavy mass particles. Next, why did they select gold foil? Because thin gold foil of approximately 4 and 10 raised to power minus 5 centimeter consists of around 1,000 atoms, and this number of atoms were supposed to be less for alpha particle scattering process, and the experimental requirement would be fulfilled very easily. Next, why did they choose a circular screen? Actually, they want to check the deflection of the alpha particles from the foil in all directions. Based on this circular screen, they were succeeded to identify and justify the deflected particles even near to or at 90-degree angles. Next, why is lead box used for radioactive source? The answer is because lead effectively attenuates certain radiation, for example, gamma rays, X rays, due to its high density and high atomic number.